I am the technical inventor and the business entity founder of Powereef. Now, where does Powereef differ from the rest of the offshore green energy projects? Well, first, let me give everybody a little bit briefing on my background, and hopefully that makes sense. I went to two maritime academies, and the last one was from Maine Maritime Academy, which of course located in the state of Maine in the United States, which has been for about a little over a decade a driving force. The University of Maine, a driving force of offshore wind power in the United States. Obviously, Maine Maritime Academy has nothing to do with University of Maine in that regard, but that's nevertheless state of Maine, and that's where I got my master's degree from the Maritime Academy. By training, I'm a maritime grad, but also I had my business practice in maritime industry for over a decade, which started with my position with the largest steamship line of the world, where I was a chartering manager. I was in charge of about 4 dozen or so breakbulk ships, and mainly traded through the broker in London for the world market deployment of the ships that was under my command. And that pretty much explained about my background in the training, the practice in the maritime industry. And then from there, I migrated into IT industry. Interesting, I know. But anyway, I have been a high-level architect in the IT industry, and I had my own business. I had about just basically, I had a system integration business, actively traded about a little over a decade. Besides IT, also there was a microwave communication, also as a system integrator, was part of the business as well. So that gives you the idea how do I have my background involved, engaged in IT and a microwave, which included the omnidirection microwave and also satellite business. So anyway, from there, I also went further into the power industry. I was after I ended my own business operation as the IT slash microwave system integrator. I went and joined other companies, and I started as a 4PL, the fourth party logistic 4PL manager at GE, particularly in a unit where the engines were the business or the product of the unit, and it's a very big one. So after that, I was a corporate logistic manager at another power industry manufacturer, but this one was basically the transmission control equipment manufacturer. So that's where I got the logistic for manufacturing experience, and then after that I went back to independent. Only this time I just functioned as a independent charter broker with the focus in heavy lift breakable ships involved in the oil, gas, and chemical industry. So after that, I in the probably somewhere about the last 15 years years, I have been in the oil, gas, and chemical industry, but particularly in the upstream sector for the supply chain management part. When I say that, I mean both procurement and logistic to make it full supply chain management. So the procurement part, I was on a $7 billion contract valued twin chemical plant expansion project. So for the single project, contract value was $7 billion. Does that matter? Yes, it does. You will understand why I even mentioned that, because basically that's how I would use it as a cross-reference with the size of the offshore wind market today as we know it. Well, today, at the time of this recording, it's the second day of 2023. So the idea I collected on the market and the players pretty much was updated up to about 2022, which today we say last year. So now that I already briefed everyone a little bit on my background, let me talk about the innovative part of Powereef. But before I get there, I want to first emphasize a little bit on the problem or the question today. For those who are not very up to date on the development and evolution in this industry. Today, or as we know as of today, the offshore wind power has been still today a very cost prohibitive industry. It is barely a real market of pure capitalism, meaning this is still, as of today, pretty much driven by the political will to do the right thing at the sovereign powers level. But for business to get involved, obviously, business decisions are made to justify the investment. And hopefully, not just marginal benefit or return on investment, but hopefully very good return commercially. And that's not where we are today in the offshore wind power. So why even offshore wind power? This is again for the friends who or the people who are not very updated on the offshore industry or offshore wind power industry to be particular. This is because the onshore wind power seems very good, but I don't know about other countries where the wind farms are really good with the natural resources are pretty much taken in most cases. That's one reason, at least in the United States, that is. But then I believe within the EU is pretty much the same perspective, that the landscape is becoming a concern. So many local residents, they really put on some effort to at least to delay a project like that. I do remember, if correctly, off Cape Cod, Massachusetts, the local residents rejected an offshore project over there, offshore wind, that is, for at least a decade, if not longer. And today, of course, it's getting a little better. Along the East Coast, at least 4 or 5 states in the United States, the state government are proactively promoting, engaging, and encouraging the offshore wind project. But what happened was, at the beginning, they signed contract, and so 2 contracts were going, and the problem became, again, the cost prohibitive problem. So eventually the projects were grounded. And then there were newer projects signed up, but here's problem. How much could the projects like this committed by both the entities who are doing the project and the state governments? The price they signed on for, instead of coming down by year, is actually going upward in trend contractually as the obligation of the state government to purchase in behalf of the whole state or the people of the state eventually climbs higher and higher to so much higher compared to the onshore land project or wind farm or assets, whatever the term you take. But why, if so cost prohibitive, people want to go offshore? Well, theoretically, offshore wind energy is a lot better available. But to get there technically and engineering, you would have to solve the problem because the higher in altitude above the water, the better wind energy becomes available. So to get there today, the big windmill blades goes to 266 meters long, and plus the tower, a lot of them are 300 meters tall above the water. So with that wind load, to stay stabilized, you must have the foundation underwater to make sure it's secure and stable. So the big investments go into there. We're talking hundreds of tons of, basically metal and the concrete and all that. And that becomes very I guess not very competitive. We're talking tens of millions of euros, right? For each of them. Now let's do the very simple math, right? You have all that, and each, let's say, at the 10 times of the power generation capability, but the price or the cost of getting there is so much higher compared to the same wind farm on land or onshore, right? And to go there, let's just imagine in North Sea, which is North Sea, of course, is very maritime place, very busy. How many can we put there in North Sea? Which already have too many, by the way, there. And today, by statistic, again, this is 2023. I'm not very up to date, I guess, by the months, but I think I would speculate safely that 95% of the offshore wind installations today out there are fixed windmill assets. As versus floating, we're talking foundation. There was at least 2% of the entire offshore installations that were floating foundation, which is small. And of course, engineering, we yet to see how effective, and I'm hoping those costs are coming down compared to the fixed or the fixture type of the offshore wind. So having said all that, that's where I think the big question comes in. What's the cost structure like for the offshore wind? We already know it's very high cost, but overall that's a high cost. If we break it down, what are the biggest part of the high cost from the cost structure? Well, I would say, even though all the parties, the developers, the manufacturers are, procured differently, so it varies, but I would say safely, again, about 30% of the high cost come from the installation, maintenance, and repair, and the operational cost. So that we can see what in the oil industry, we would say the upstream development cost is actually a pretty big part. And then in the midstream, again, the oil term or oil industry term, the midstream, the maintenance and repair is also. And then here's another problem. The life cycle of such an installation, give it some 10 years, some 20 years, and then basically decommission. So with all this cost, there is no scale of economy, meaning if you expect to have more deployed, commissioned, and put into service, you hope the cost will come down when the total deployment scale. No, there's no scale of economy. So now we know all this about the equipment, about the installation, about the maintenance and repair cost. This is where Powereef takes on such a problem and take a crack on the high cost. To begin with, my design is modular design. Again, that's basically pretty common trend in the oil and gas industry. Basically, modular design has been a thing. So I applied that concept. So instead of doing all that offshore fixed and some floating foundation today, my design does not have any blades at all. That's the big difference. And because of that, the whole wind load business changed. It's a totally different concept. But more importantly, this design enables the possibility of modular design, so it significantly cut down the cost on the installation. Make the installation pretty much just haul the thing to the side and hook it up in between, because that's basically a group connecting to a central island. So the installation becomes very simple, straightforward, and easy. Most importantly, the cost significantly costs down. Why? It's floating system. It's not about floating foundation, just float it in the water. And you haul by the ship, any conventional ship that, in my design, I don't need any special ship. And that's a big difference. And I'll talk about that later. So the work ship haul it to the side, and then the tugboats basically put them together one by one in a group. That will knock down the installation cost, I would say at least 10%, if not more, compared to the current installations out there. That's one. And then we talk about the safety, right? In the United States, it's OSHA, and there are other things in the different countries, different jurisdiction, different law, but basically the same idea. Now imagine human being climbing up and down 300 meters tall, a pole on the open water. Is that safe? I don't think so. Nevertheless, it's not safe, and it is cost very prohibitive too. So in my design, it's all drones and robots operating. It's basically, in most cases, unless extreme exceptions, no human involved in the M&R. So that's another cost knocking down. And then the whole system designed mechanically self-adaptive, meaning whatever the weather condition, the natural resources given around, the mechanical self-adaptive system never has to shut down because of the strong wind. So with this mechanical adaptable capability, the software remote control command basically enforced by the operation research optimization to provide the optimized performance within the given resources, the natural resources, and then the enhanced deep learning to further provide the suggestion on how to improve economically the resource of the system. So that allows the constant improvement from one level to the next. And overall, all this means the deployable commissioning or commissioned life cycle becomes well extended compared to the current installation systems. It can be at any time on the go within, matter of number of hours or days at maximum. It can be redeployed at any other work site. And this is something the current system cannot offer. So basically, with the modular design, that can be massively produced at quantity, and then the repair becomes basically replacing the single asset out there, haul it back to the shore, and basically repair if it's a major repair. Otherwise, the routine diagnostic capacity and the mountable robots would perform the simple task, the routine task of maintenance. So this is how the cost can be bringing down or brought down at about projected 30 to 40% from the system on the average of the installations out there today. And more importantly, this is the mechanical part and software control part, but this is all just technical improvement and engineering solution. But more importantly, this is all about the business model. All this is to enable the business model that's basically nobody has been using it. So I'm going to have a patent on that, which basically takes out all the upstream development problems off the plate from the future operators, which I believe would be the currently those parties engaged only in oil, gas, and chemical. But of course, some of the oil companies already started offshore wind business. But anyway, my business model will absolutely make it a lot simpler. Most risks from the upstream basically mitigated, controlled, and isolated from the midstream. So the players would only come in to play the midstream from the automated online remote operation management center, a software platform, and make it so easy. And then because the software controlled and the whole system capacity can be provisioned, the downstream becomes smart. You can plan and you can provision your power output capacity, and so that you can go and match up with the demand fluctuation of the power grid onshore. So in a nutshell, that is where and how Powereef differs from the rest of the installations already out there. Of course, there has to be a proof of concept to basically do the simulation design, to test out the scenarios, all the scenarios virtually, and to arrive at the configurations of a prototype, and to make sure it actually does exactly what's projected, or how to reconfigure to get there. But nonetheless, you got the idea. But if you still have your questions, feel free to reach out and engage, and we'll see if we identify the mutual interest. My detailed presentation should address your concerns. Until then, have a great 2023.